The lecture on insert failures and their remedies offers a range of valuable outcomes for anyone working with cutting tools and CNC machines. By understanding the causes and solutions for common wear types, flank wear, crater wear, plastic deformation, and edge fractures, attendees gain practical knowledge that can directly improve their machining processes. These outcomes include 1. Enhanced tool life. By learning to identify wear patterns early and implement appropriate remedies, attendees can significantly extend the lifespan of their inserts. This leads to reduced downtime and lower costs over time. 2. Improved machining quality. Understanding wear mechanisms and how to address them helps maintain consistent machining quality. Parts produced will have more reliable dimensions, surface finishes, and overall performance. 3. Cost savings. With longer lasting inserts and fewer tool replacements, as well as optimized cutting parameters such as reduced speeds, feeds, and cutting depths, attendees can lower their tooling expenses and improve overall cost efficiency. 4. Increased process stability. By addressing factors like vibration, coolant flow, and cutting conditions, machinists can achieve more stable operations, reducing the risk of unexpected failures or tool breakages during production runs. 5. Greater confidence in problem solving. Learning to diagnose wear types and apply the proper remedies empowers operators and engineers to troubleshoot issues quickly and effectively. This leads to more confident decision-making on the shop floor. By the end of the lecture, attendees are equipped with the knowledge and strategies needed to optimize their cutting operations, maintain high-quality output, and minimize disruptions caused by premature insert wear. As you're using insert, it is definitely going to wear out after some jobs, but sometimes insert gets wear out so early. So at that time, you have to check some parameters. So here I'm going to show you some insert failures, and I will also give some solutions to avoid these failures. So our first failure is flank wear. This is how flank wear looks like. You may have seen this type of wear. If you get this wear after many jobs, then it's okay, as these insert have some particular life. But if you get this wear so early than required jobs, then there is some problem with your machine or insert. So what are these causes so that we are getting these wear so early? So see, high cutting speed, material cutting speed may be high, then preferred or low wear resistance carbide grade. That means your insert may have low grade, which is not suitable for that job or material. So these are the cause for this type of wear. Now let's see it's remedied so that we can avoid this type of wear. So use harder material grade for that insert. So that insert will easily cut that material of job. Also reduce cutting speed. That means reduce cutting speed with the help of feed. So reduce feed to get better life of that insert. And third remedy is to increase coolant pressure and check coolant direction. So you have to check whether coolant is properly directed on your workpiece or not. If coolant is not properly directed on workpiece, then lots of heat will get generated and they may cause this wear. So properly direct that coolant on workpiece to avoid this wear, and also increase coolant pressure. Our next wear is crater wear. So it looks like this. So as you can see, we are getting this wear on upper side of insert. So this wear occurs due to excessive cutting temperature and pressure on the top of the insert. So to avoid this excessive pressure on upper side of the insert, we have to reduce cutting speed, use more wear resistance cutting tool material. That means use high-grade insert. These two remedies we have already learned, and increase coolant pressure and check coolant direction. This also we have covered. So as you can see, these 4 common remedies are there to avoid wear of insert. So whenever wear occurs, you have to try with these common remedies. Our next wear is plastic deformation, and it looks like this, and this wear occurs due to high temperature. So what to do to lower this high temperature? Reduce cutting speed, check coolant direction, increase coolant pressure. Here we have new remedy to reduce cutting depth. That means you have to reduce depth of cut to avoid this wear. So these are common remedies which we have to use while operating machine. Next wear is edge fracture. So this whole corner gets damage in this wear, and this wear is caused due to excessive load on insert. So to avoid this wear, use high-grade insert, reduce cutting speed, reduce depth of cut. Here they have suggested to increase corner radius. So this nose radius we have already learned. So try to increase nose radius to avoid this wear, and check tool stability if vibration occurs. If any vibration present in your CNC, then try to remove that vibration. Here I have taken some basic wears that normally occurs in insert. So if you learn these 4 wears, then also you get an idea about how to deal with any wear and how to increase insert's life. So here we have learned insert wear as well.